All right, let's get started. So today is the next debugger lecture. I got two phones. All right, so now is the next debugger lecture. So maybe next semester I got to rearrange things. We don't get hardly any debugger in the first half of the semester, and then we get quite a bit of it right in a row. So let's do another debugger lecture. I don't want to write too much code today. I got code already written. It's got bugs. We're going to get rid of the bugs. That's our goal today. With any of these open-ended coding lectures, I'm open to getting off track and going off on tangents and stuff because I would like to tailor these lectures towards the bugs that you're actually having trouble finding. That would be ideal. So if you can let me know, hey, I got this bug. I have no idea how to debug a linked list or something. We can gear it towards that, at least to an extent. I got to get an example ready real quick and everything. But I'd rather do that. Other than that, I do have some examples that I'm going to go through. But if you have questions, I'm happy to get off track if what we get off track with is going to be more useful to you than what I have prepared. So with that in mind, let's do it. Anybody have questions before we get into it, actually? Perfect. All right. So the first code that we're going to debug is very similar to what we saw last time. We have this load countries method. It's written a little bit differently. I pushed this to the repo a few hours ago, this debugging in week 10. If you didn't pull or you're having trouble pulling it for whatever reason, this is actually example 2 from week X. Just rearranged the content a little bit this semester. Week X was even later for debugging, way too late for debugging. So I got a little earlier. I think it's got to be even earlier, though. Debugging should come probably in the first testing week, honestly. We should have a whole debugging lecture, which is week 3. Week 3 of the semester, I think, is a good spot for it. But here's the method. It's a little bit different than what exactly we coded last time in country's example. Country population is going to be the same idea here, a little different. There's, like with most things in programming, there are so many different ways to approach the same problem that gets to the same end result, gets to the correct answer. So we'll start a new hash map like we did last time. And then our first deviation, we're going to call a read file helper method, which looks just like the method that we had in lecture. In lecture last time, that sounds weird. In lecture last time, we put this code right in the method that we were writing. In lecture, in the slides on Monday, this is what it looked like. So this is what it looked like in the slides. We had a method that's going to read all the lines of a file and return all the lines in an array list. So for this example, I'm using the helper method, which is probably a better idea if you're going to read a lot of files. For your homework, you're going to read the songs file, the movies file, and then in task 7, you're going to read a movies ratings file to populate our movies with ratings so we can compare songs and movies by their Bayesian average. That's eventually what we're going to do in task 7 to get some top 10 lists, top 20 lists, whatever, top K lists in general. So when you're reading 3 different files, sometimes it helps to have this as a helper method instead of having this exact code multiple times in your program, in your project. So I'm writing the helper method, calling it, and then getting the lines of the file that way. And then to remove the header line, since I'm storing the array list in a separate variable, whereas before I just read the file, I did read all lines right in my loop and read the file right in the loop. Here, since I'm storing in an array list, I'm going to use an array list method to remove the header. I'm going to remove the value at index 0, which should be my header line. It's going to be the first line of the file. Iterate over the values. The next chunk of lines, these are all the same. We're going to split on commas, get all the values into our variables. We're going to call the location constructor. I did it inline right here last time. Here I'm creating a separate variable for it, calling the city constructor, checking if I've seen this country before. If I have not, lazily initialize the empty array list for that country. Then whether it was initialized or not, add that city to the array list for that country. And then we have another method here, country population. We're going to call the load countries method that we just went through. to get this hash map that maps countries to all the cities in that country, we're going to check if the country we're looking for exists. What we want to do with this method is return the total population of this country. So if we've read that country, if it exists in our data, then we're going to compute the population. If it doesn't, just return 0. If the country doesn't exist or we have no record of this country, we're going to return 0 as the population. If we do have a record of this country, we're going to accumulate population equals 0, accumulate based on all the cities, and then return that population that we computed. Our tests start out the same way we saw last time, same data and everything. Oh, I set myself up for a bad time in one of these things. Anyway, and we have one extra test, but those other tests are the same we saw. And then test country population is going to give us a test case for that population. For this one, we are actually using the entire cities.csv file, which I said, don't do that. Don't ever do that. That's crazy. I went on this whole tirade last time. Don't use the whole cities.csv data. And we're going to use it right here. These are two different situations, a little bit nuanced, so let's explain the difference. Last time, we were returning a hash map with all of the data from the file, and we're not going to write a test case for that. Here, we're writing a test case that's going to find the population of a specific country, and that we can actually write a test case for using the entire data. What I'm going to do is find a country with a very small number of cities, so it's easy to compute my expected value. I found the city VG, or country VG, which somebody in the last lecture pointed out. It's the British Virgin Islands. And our data only has 3 cities for this country, so it's easy enough to add these things up. 84 plus 8449 plus 355. Add those all up, and I should get the quad 8s from my test case. So we're using the entire file, but it's simple enough to generate my test case by adding a few values together. Can you show how splits works on comma? Yes, I can. I'll do it in order here. That will be the first bug that we find. I'm going to run the debugger, and I think that will help. I have a lot of stuff I want to talk about with the split method. I shouldn't say a lot, but a few minutes. If that doesn't answer your question when we get there, make sure you ask me again, and don't let it slip through the cracks. But I do want to talk about the split method when we get there, because having the debugger show all of the values really can be eye-opening of exactly what the method's doing if you're having trouble understanding it. How did you find that city? That one I also want to talk about. I like these questions. My computer doesn't. My computer doesn't want to do anything. In country's example, here it is. So in country's example, in the main method, so this is in the repo, you can take a look at it. This is how I found that country, is I wrote some code, and this also sounds hypocritical, so let me explain. I wrote some code to help generate my test case, which sometimes is something you can do that doesn't have the issues that I talked about. So let me explain. Let's first go through this code. I'm going to call load countries, which is the method we're testing even, or rather, the method we're testing is calling this method as a helper method. So this is really bad off the start. Get my countries. I'm going to have some threshold. I'm going to say, give me all of the countries with 3 or fewer cities. That's what I want to get. I'm going to create a new hash map with just my small countries, iterate over all of the countries, and if the array list of cities for that country has size less than or equal to my threshold, add that to the small countries hash map. And then for my purposes, I'm just going to print all the cities and all the small countries to the screen. And this is where I'm using my city toString method. The toString method I wrote to simulate a line in the data file, print it in that same exact format. And if I run this code, I'll get all of the countries or all of the cities for every country that has few cities. I don't know why I keep getting this error. Like, I just ran this code last lecture.
Did you do the same thing?
I might have done the same thing. Oh, because I stashed my changes. But why? I don't know why that's, like, this is still 20. I need to delete this off my hard drive. I think that's my next step. I never want Java 19 again. I think I did the same exact thing. It was the stash. Something when I stash my changes. All right, and then that's going to print out, let's get my POM file out of the way here. And that's going to print out all of my cities in small countries. It's not that many of them. For how many lines we have in that file, a lot of those lines are from very large countries. Some of these countries have lots and lots of cities. So the reason I get away with this, the reason I can write this code to help me generate my test case is because it's not actually generating my test case. I am using this code to narrow down my search, and then I'm going to find a country that has few cities. And for my purposes, I want exactly 3 because 1 and 2 is a little bit too small of a test case. Realistically, I should have multiple test cases for testing the population. I only have 1 test case. That's not suitable. It's not actual testing. I would have one with 1 city, then 2 cities, then 3 cities, and maybe one with 5 or more cities eventually. But at least 3 cities, that's a pretty good threshold that is going to expose a lot of bugs. So I find my country, and then I go to my data and find that country and verify. This is the key point. This is why I can get away with writing code that's using the code that I'm testing to generate my test case for the code that I'm testing. Like, it's multiple layers of bad because I'm actually calling the method I'm testing, or at least the helper method that the method I'm testing is calling. It's very, very bad. But the reason this is going to work is because I'm manually verifying the test case. I'm using this to narrow down my search, going to the file and verifying that this country has very few cities. Even if these cities might be out of order, I searched VG, comma, I got 3 results. I'm confident that this is a country with just 3 cities in my original data file. So I'm manually verifying. If there's a bug somewhere in my code and it's not printing out the right stuff, it's printing out some countries that actually have lots of cities in them, I'm going to find that out because I'm going to go to the data file and say, wait, that's wrong. That's completely wrong. And then to generate my test case, I'm doing math on 3 values. I'm going to pull up my calculator. Hopefully I have all the numbers right. I think I do. And generate that test case manually. But I'm narrowing my search with code. Any bug in that code, I'm going to immediately find out. A bug in that code is never going to make it to my final test case. So in this specific situation, I actually got away with using code to help me generate my test case, at least to find the test case. In a few of these cities, when we use this data for homework assignments, this is a task that students would have to do, is find these small test cases. We don't use this data anymore. Someday, maybe next semester, we'll bring it back. But finding a city, man, I cannot get this right in my brain. Finding a country with few cities, especially finding a country with only 1 city, was a very desirable thing to have for testing. So you weren't going through, like, scrolling through this code and trying to find a small country is very difficult. And this is one, I used code to find this one, this AI. You'll never find, I shouldn't say never, but it's extremely hard to find this one if you're scrolling through all of the data. It's right here, but that I really blends in with the L's. And I scrolled past it many times and never knew it existed until I wrote code to help me find the small countries. You're scrolling by, okay, AF, 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 AG, AL. You don't see that AI unless you're really looking for it. But that's the first country in the file that has only 1 city in it. So that was the one we all like to use for testing. That's like basically everyone had this test case. Because I pointed it out in lecture too. I did the same thing in lecture. I said, hey, use this one for your test case. So there's a reason everybody had it. But yeah, finding the small countries, not easy if you're scrolling through the data. Some of these countries have ridiculous numbers of cities. let's run these tests. 15 minutes in debugger lecture. We haven't ran the debugger yet. Let's do it. So all three of our tests are failing. All of them. Whenever I have lots of tests failing, where am I going to start? My barometer tests. I always like to have that one test for each method that's super simple. I don't have it for country populations. Probably should just add more to the repo. I wrote that method during a lecture, so it's that test case during a lecture, and I just never went back and added a bunch more after the fact. But test single city, this is my barometer test. Even this one's failing. That means my code is completely messed up. So I have a barometer test case that's failing. That means something's fundamentally messed up with my method, and that's the one I'm going to use for debugging. I'm not going to try to debug this test with multiple cities with a whole bunch of stuff going on. That's just going to make my head spin in circles. I'm going to get dizzy, and I'm going to get frustrated because it's going to be a lot harder to see what's going wrong. I want my simplest test case that's failing, and that's the one I'm going to use to start my debug process. And that's the advantage of having these simple test cases. If they're failing, you know where to look. Look at the simple one that's failing. So let's run the debugger. Make sure I hit the right breakpoint. I've been setting a lot of breakpoints today. And let's talk about that first. Where to set the breakpoint. When I have a test case that's failing, the first place I'm going to set my breakpoint is on the assert that's failing. So when I compare, or not exactly on the assert, but on the method I just want to see my data. So on the method that's doing the comparison in this case, I don't necessarily want to look into this method. I will if I think I can learn something from that. But first, before I even dig into that, set the breakpoint right here before the check occurs. Expand everything and take a look at what I got. I want to see what's in these data structures and manually compare my actual versus expected. Because the part that's failing is going to be one piece of data that's failing. I don't want to debug that. I want to look at the whole picture, because if one piece of data is wrong, usually it's a lot of data that's wrong. So I want to look at the whole thing. So my expected US, just Buffalo, population, location, that's my expected. Let's expand location too. And my actual is Buffalo as a key, which already tells me something's way wrong here. Buffalo is the key. The key is supposed to be the country, not Buffalo. It should be US. And then when I look at the city, I have just one city in the country and one country, so that's looking the way that I expect it to be. But then name, US, region, New York, country, Buffalo, population, lat long, all look good. But what stands out is name and country. These look backwards. This is a very common mistake to make. We have let me not get into that yet. Let's figure out why we're making that mistake. So I found what the symptom is. This is the symptom of my bug, is that the name and country are not in the right order. Now is when I'm going to reset my breakpoint to the method call, the method that I'm testing, go through that method call and figure out why those values are not in the right order. So now I'm going to restart my debugger. It's going to hit this breakpoint. I'm going to go into this file, or into this method, and I can start going through my code line by line. And I'm going to get into some situations like this where I'm in the abstract collection constructor. I'm in the object constructor right here. I don't want to be in any of this stuff. This is where I use the step out. Whenever you get lost in a sea of Java code that you're not debugging, I'm not debugging the object class right now. I'm not debugging that. I'm confident that it does what it's supposed to do. But this is kind of neat, though, because we can see that in the array list constructor, we called all of the constructors of its superclasses. Array list extends abstract list, extends abstract collection, extends object. So we can see all four constructors on the stack. So I guess it's kind of neat that we ended up here in a lecture. But I really don't want to be in here when I'm debugging. So I'm going to use step out. That runs until the current stack frame ends. Abstract collection stack frame, done. Abstract list, done. Array list, done. And then we finally get back to our code that we're actually debugging. I don't want to do that again. So I'm going to start using step over when I have a line that's all Java methods. This is the array list constructor, the read all lines static method, the get non-static method. This is all internal to Java. I'm not debugging Java. I think Java is doing what it's supposed to be doing. It's my code that's broken. So I'm going to use step over, skip over all the method calls on that line, skip over all those stack frames, and get into what I'm interested in. I also don't want to go into the remove method of an array list. I'm confident that works. And get into my actual stuff. All right. Now we're iterating over the lines of the file. Lines is size 1, and it's just the line that we're interested in. So we successfully removed the header line. We're feeling good about that. We enter our loop, and we're processing the line for Buffalo. We're feeling good about that. Everything's looking like it's adding up the way we expect. And then we're going to call splits, as list, array list, a whole bunch of Java method calls. So I'm going to make sure I click step over so I don't get into any of those method calls. And here's where I can finally answer this question. Can you explain how split on commas works? And this is it. So split on comma is going to take this string. This is a non-static method of the string class. I can show that, right? We're ready for things like that. So we're in the, oh man, maybe we're not. This is the string class. Yeah, there's a lot. So this is the string class, which has a split method, which takes a string and is going to split on that string and return an array list of strings. We can look at what it actually does. This is what it does. We're not interested in that. The end result, or we're not interested in how it does what it does. Maybe you are. Maybe, I mean, I kind of am too, but not right now. But what it does, the end result, is it's going to take a string. It's taking this string right here that has commas in it, and it's going to separate the data by those commas and return an array list, it returns an array, as we just saw. We're converting it into an array list. But it returns an array list with one value in the array list for each value that's separated by a comma. So US, comma, Buffalo, comma, New York. That's US is going to be the first value in the array list. Buffalo is going to be the second value, the value at index 1 in the array list. New York is going to be the value at index 2. And then this number, this number, this number as the next values in the array list. So we get an array list of size 6 when we parse this string, or when we split this string on commas. That's what our split method's doing. We take one string that contains commas, well, actually this one string that contains commas, and split it into, for our purposes, an array list with each value that was separated by a comma as a separate entry in the array list at a separate index. And we're going to get the values at each index. Splits.get of 0, splits.get at the value at index 0 should give me US. Get 1, it's going to give me Buffalo. 2, it's going to give me the region. 3, parse it as an int, population, etc. Is it true that back then task 6 needed a time extension because people's code would time out due to using for loops? Not that I recall. Task 8 definitely did. It didn't need an extension, but I removed one of the tests that was causing the timeouts and just letting y'all use inefficient code. I don't think task 6 had the same issue, except some students don't listen to my advice and use the full... this is different data. It's not the best thing. But using the full song ratings.csv and the full movies.csv, if you're using those test files and you have inefficient code, it can time out in Autolab, but you also see that when you run your tests in IntelliJ. Like, it's not going to time out my correct and incorrect solutions, but if your code is inefficient and you're using the full data file, you'll start feeling that pain. These numbers are large enough that you're going to feel that pain. when you have, I think it's over 100,000 movies, right? Over 100,000 movies, that's fine. That 100,000 is a tiny number to a computer. But once you have a nested for loop, and you're looping over every movie and then looping over every movie inside that loop, now you're squaring that to some... I can't do math anymore. Right, 100,000 squared? 1,000... Oh, my eyes. 1,000 million... billion, 10 billion iterations of that inner loop. Now you're seeing a lot of inefficiency. 10 billion's getting up there. That's a pretty good sized number. It's still not crazy, but when that 10 billion, the worst thing you can do is when that 10 billion includes file I/O, then you definitely feel that pain. Then you're getting into minutes of runtime. So if you iterate over all the lines of the file, and for each line you read the file again, and iterate over all the lines. That's the worst thing that students do that will really crush your runtime. You want to make sure you're only going to the file one time total. If you're going through the file 100,000 times, it'll time out. But it'll time out in IntelliJ. So can you show how splits on commas works? If that didn't cover your answer, if you want to know more about that, I'd be happy to talk more about it if you have a follow-up question. But I did get to it. So let's jump over a lot of these. I don't want to debug the Java code, but I do want to make sure we did get all of the values that we expected. So here's our line, and here's our value: country, name, region, population, latitude, longitude. Everything looks like it got in the right variable that I expected to. So we're looking good so far. We split our line. We did all our CSV stuff. We're reading the file. Everything is going on fine there. And then we get to the city constructor. When we get to the city constructor, let's make sure everything's still fine here. I can't even find, oh, there it is. Country, Buffalo, region, New York, name, US. And here we see our bug. It was a mismatch between the city constructor parameters and the arguments that we gave the constructor. Running the debugger, that jumps right out at us. But this is a very common situation, common enough that I even made this mistake in the other lecture on Wednesday during lecture. I mean, I would have caught it pretty quick, but it ran out of time in lecture and went uncaught. But this city class and the song class both have 3 strings that they take as constructor parameters. And since they're all the same type, the compiler's not going to tell you if you got something wrong here. So we can have a mismatch, and often students do have mismatches here, where the constructor parameters don't match the constructor arguments or don't match the handout, the spec sheet. Our task handouts are basically the spec sheet that you would follow on the job. You get a spec sheet, here, build this. That's effectively what they're supposed to be. So it doesn't match the spec sheet, not what the customer is expecting this method call to be, or other people on your team. You'll have a dev team with multiple sub teams, and each one of you will be responsible for part of the project. Ideally, you'll all have spec sheets, and here you have to build this class, build it to this spec, and then another part of your team is going to use that code and expect you to have it built according to spec. If the constructor parameters are not in the order that were agreed upon, or your other side of your team isn't using it in the right order that you agreed on, things are going to get jammed up. Things are going to get messed up. Very common mistake to make. And of course, that's why the song class takes 3 strings. It's so you get used to looking for that, looking for the order of your parameters and arguments, and making sure they're in line with the spec sheet. And I see this bug surprisingly often. By surprisingly, I mean 2 to 3 times, which is more than 0, after task 2. I don't understand this. If any of you have done this, if you can let me know what the hell happened. But you'll get past task 2, what some students will do. Very few, but not 0. Get past task 2, everything's fine. The song constructor's great. And then when they get to task 4 or 5, way later in the semester, their song constructor will be out of order according to the spec sheet. I don't know why this ever happens, why you would ever go to that constructor and change the order of your parameters after it's been tested in task 2. But it's a really tough bug to find. Like, I look for it now. It's one of the first things on my checklist. But it's something that TAs don't necessarily look for. If you come to office hours asking about a question on task 4, TA is not necessarily going to go through and debug your task 2 code. They're not going to really know to do that. So it's a tough bug to find if you're not looking for it. What I like to do, one of the things you can do to prevent things like that is if you have a directory with multiple tests in it, multiple test classes, like you do your test directory on the homework, you can right-click the package and run every test in that entire directory. I do this out of habit, more maybe out of paranoia, is when I have a whole bunch of tests in a directory, I'll run every test in the whole directory fairly often just to make sure I didn't break any code from previous functionality that I've built in a project. It's common to break functionality later in the project. Not very common to do it the way I just explained, where you go back to tested code and intentionally break it. I don't know why anybody would do that, but they intentionally break it and intentionally change, I shouldn't say intentionally break it, intentionally change code that's already been tested, especially after you've had Autolab say it's good. I don't know why, but students do that. But if you run all of your tests every once in a while, run every single test and make sure they're passing. These ones don't, but make sure they're all passing on a regular basis, just to make sure you didn't break old functionality. Tasks 2 through 8 all build on each other. Everything, by the time you're done with task 8, all of your tests should pass. All of it should still be passing. These are intended to fail. This is back when we said don't use equal equal to compare two doubles. Don't use equal equal to compare two strings. And this one was writing a test that exposed a bug that we didn't handle, the edge case of 100. So these are supposed to fail, in case you're wondering. Oh no, I lost my debugger. So I'm going to set a breakpoint. I kind of lost where I was. I'm going to set a breakpoint on city. Run my test cities in the debugger. The way we're using splits, it'll create one array list for each city. Like, where did we handle the logic of creating an array list for each city for a country? We didn't. So we have one array list per country, and it's an array list of cities. And for each line in the file, we're creating one array list of strings with all the data for just that city for that line of the file. By the time we get to the end of this loop, we're going to come back to the beginning of it and create a new array list for the next line, for the splits of the next city. Since this is in a loop, we're not getting array lists after array list after array list. We're only creating one array list at a time. Getting to the end of the loop, throwing that array list away, it's no longer in scope, and then creating a new array list the next time we hit that code in the next iteration of this block. I missed this one. Does UB have a class that goes over implementing the programs we code into websites, apps, assume that means etc. Does UB have a class that goes over implementing the programs we code into websites, apps? Not 100% what you mean. If you mean making web apps, CSE 312, the other course I teach. I do 116 and 312. Those are courses I've settled into. If you want to learn how to build web apps, 312. Take that one, if that's what you mean. All right, so we got back to where we were by setting a new breakpoint. And we can look at our city constructor, country, region, name, region, country. We're backwards. And for this, I'm going to assume, I'm not going to make the mistake I made in the other lecture. I'm going to assume that we're out of spec with the spec sheet and that our constructor is in the wrong order. So I'm going to change the constructor. Otherwise, I have to update all my test cases like I did in the last lecture. It's boring to watch. And I'm going to fix my constructor. So I went back, if this is a homework, I went back to the homework doc and it says region, name, country, and I say, oh crap, my constructor's in the wrong order. So we found a bug, we fixed a bug. That's when I like to shut down the debugger and just run my tests again, because I might be done. Like if I'm done, I want to know that right away. I'm not going to keep stepping through my debugger after I've found and fixed a bug. Now I have another bug, so I'm going to go back to the debugger to fix this one too. But I definitely fixed a bug because I got two tests passing. So it's looking like my load countries method is working the way I expect. So I'm happy about that. But I have test country population not working the way I expect. And I don't have to run the debugger to find to look at my data because it's all right here. Actual was 355. That's not looking good. So I know I know what the symptom is. So now let's go into this method and figure out what the bug is. I have a whole bunch of other breakpoints that I'm going to have to remove. So I'm not going to go through my code and remove my breakpoints. I'm just going to let my debugger find them. So I'm done with this breakpoint. I'm going to remove it. Click resume. Load countries, remove that breakpoint. I'm done with that one. Hit resume. Now I'm in country population. Get into this one. Load countries we already tested, but I do want to make sure it did what it's supposed to do. Code runs so slow in the debugger. I shouldn't have. Oh, no, because this is the full, because we did the full file. That's right. And we can go through all the data. I'm not going to. The debugger doesn't even show me all of it by default. I am not going through all that data. That's why we don't usually use the full data file for testing until we're ready for that. I mean, in production, you do want some large data files that you're going to test with, but it's a lot to set up those test cases. So countries.contains key, we got in here. That means this VG is one of my countries, and I'm going to iterate over the cities in that country. I expect this to be 3 separate cities. So let's take a look at the first city. We got Little Harbor with 84 people. Population, get the population, 84. Next city, Road Town, 8449. Population, 8449. We should pretty simply find the bug at this point. We're not accumulating. Whoa. Wait. There we go. We weren't accumulating. We were just replacing each time. So we didn't get this value plus the old value. We just completely replaced. The next city, 355. It's going to replace the population. And when you change code like that, the debugger will not use the new code, by the way. There's something called hot swapping. You can get it to, but I don't know. I never bother. I just restart the whole thing. And actually, I found a bug, fixed a bug, so I'm just going to rerun my test without the debugger and hope I green bar. And we did. So I'm not super confident the code's, I'm pretty confident personally, but I'm not super confident the code's correct based on my test cases because I only have 1 test for the population method. Only 2 tests for the other method. Not a very strong test suite, but I'm feeling pretty good. There's not too many things that can go wrong here either, but I would want more tests to actually build my confidence that my code's right. I'm just not going to do that during lecture. We got other things to do. So any questions about this? Okay. That's I only had 2 bugs in that one. I only had 1, but I had to add that equals instead of plus equals just so I had 2 bugs to talk about in this lecture. The last one I only had 1. But let's jump back to this item code. We didn't get to fix all of the bugs in this one, so let's go through this one. I don't know if we fixed any of them in this lecture. We identified one of them and then didn't have time to fix it. So let's go back to this item test. Just a reminder what this is. This is an item. It has price and description and any number of sales that accumulate multiplicatively. And then we can ask an item for its tax based on, it's tax based on some tax rate. Then we can print out receipt lines with the description of an item and the price including tax. In a very specific format. So let's run the test and see where we're at with this. And we have some bugs to fix. Yay. That's what we're here for. So test a receipt with receipt line with multiple sales. Test a receipt line. Test an item with multiple sales. 2 multiple calls. Test an item, a price with 1 sale, multiple calls. When I have a whole lot of tests failing here, I want to start with my simplest test that's failing. And the receipt line methods really depend on everything else working the way it's supposed to. So I don't want to start with those ones. Those ones are going to be hard to debug. And oftentimes, your bug will not be in the method that's broken. So when test populations, if that had plus equals to begin with, like it did in the last lecture, which y'all weren't here for, but I'm referencing something y'all don't even know about, weren't here for. But anyway, if that was plus equals, if I didn't have that bug, that test would still be failing, but that method would have been perfect. That method would have been fine. The reason that test was failing was because one of the methods that method relied on, its helper method, was broken. So that can be a problem. If you start with the wrong failing test case, you might be debugging a method that is perfectly fine. And these are the cases where you go to office hours, you say, TA, this method's broken, and they try to find your issue, and they're like, man, this code looks great. Because it is. Because the method was somewhere else. It's because you had your song constructor parameters in the wrong order, for example, like the example I gave earlier. So it's not always, and it's a reasonable thing to do. If you're going to have a method that's broken, a test case that's failing, you're going to look in the method that's broken. But it's not always the case that the method that's broken is actually broken. If it relies on helper methods, it might be the helper methods that are broken. So you might be looking in the completely wrong place. So to limit that, to mitigate that, I want to look at the simplest test case that's failing, and hopefully you have test cases for all of your methods, and try to identify the simplest one. Ideally, the one that doesn't call any other methods. So I'm going to start item price with 1 sale, not the one with multiple sales. And I'm going to test this one. We identified this bug last time, so I won't go into identifying the bug. We saw that the bug was that we were updating the instance variable of this item whenever we asked it for its price. Price is a getter. When I'm just getting something, I don't want anything to change on that value. A getter should not have side effects. This is a common thing when you first learn classes. You don't necessarily think of that. So item.getPrice, it's a $100 item with a 20% sale. I expect it to be $80. I'm going to step over. I don't want to go into anything right here. The item, oops, I'll back up. The item is a $100 item. After I call getPrice, it's an $80 item, which is what it's supposed to be. That's what I expect the price to be. Everything's fine, kind of. But I changed the state of the object. I went over to the heap and made a change to an instance variable to compute that value. So now when I call getPrice again, I'm computing the sale price on the sale price and going all the way down to 64. I'm applying a 20% sale again and giving a bigger discount to the customer. If I keep doing this, every time somebody buys salmon from me, they're getting another 20% discount. I'm going to go out of business very quickly, or at least hopefully I run out of salmon before I go out of business. But they're going to get a lot of cheap fish here. So to fix this, I want to make sure I never update price. So I'm going to use a separate variable, which I'm going to call price, just to be confusing, and use the local variable to the stack frame, never updating this value. So I'm going to get the value from the instance variable and then use this as my temporary variable that's going to be changing, that's going to get the sale applied. But the instance variable never changes. I'm not going to have any side effects in my getter. I found a bug, hopefully fixed a bug. Let's run our tests and see if it's actually gone. And I'm getting more passing. All right, test item tax with sale is failing. So next bug. This one we didn't get to. Actually, this one I added just in between lectures now. So we have an item with 4 sales, tax rate, and we expect the tax to be 104. The tax is actually 155. So let's take a look at why our tax is more than we expect it to be. So into this method. And we don't get much information. This is one case where we're doing probably too much in one line. For debugging purposes, it can help to break this into multiple lines because the debugger can't do much for us here. But we have a price of $19.95. We have a tax rate of 7.75%. We're going to multiply those two together to get our tax for this item. What's the issue here? Anybody see it? We're running out of time, so I'm just going to say, what is it? And then shout out the answer. So we're not changing the state of the values, but we're computing tax. This is more of an application-specific bug. We're computing the tax on the base price. We don't want to do that. We want to compute the tax on the sale price. If something's on sale, you want to pay tax on the sale price, not the original price. If something's 99% off, you don't want to be paying 100 times more tax than you're supposed to. So we want to call get price, not this dot price. This dot get price. That should get rid of that one. And my favorite one, I didn't leave enough time to talk about it in this lecture, but my favorite one, our receipt line should be serial 550, including tax. We're getting serial 5, and I had to cheat a little on this one. 5.00.5. What's going wrong here in our receipt line? And I'll just have to give the answer here. Not this one. Oh my goodness, I have too many breakpoints. Receipt line. So for this one, the plus operator, this is the plus sign operator is a binary operator. It only takes 2 operands. So when this line is executed, it has to be executed left to right, 2 values at a time. When these 2 values are added, they are concatenated. This is string concatenation for the plus sign. And then this returns a string, and it's a string plus a double. Java is going to interpret that also as string concatenation. So we're going to concatenate serial : $,